Eta Carinae is a stellar system in the constellation Carina, about 7,500 to 8,000 light-years from the Sun. The system contains at least 2 stars, of which the primary is a luminous blue variable that initially had around 150 solar masses, of which it has lost at least 30. A hot supergiant of approximately 30 solar masses is in orbit around the primary, although an enormous thick red nebula surrounding Eta Carinae makes it impossible to detect this companion at optical wavelengths. The Eta Carinae system is enclosed in the Homunculus Nebula, in turn a part of the much larger Carina Nebula, and currently has a combined bolometric luminosity of over 5 million times the Sun's. It is not visible north of latitude 30° N and is circumpolar south of latitude 30° S. Because of its mass and the stage of its life, it is expected to explode as a supernova or hypernova in the astronomically near future. Observational history: when Eta Carinae was first catalogued in 1677 by Edmund Halley, it was of the 4th magnitude, but by 1730, observers noticed it had brightened considerably and was, at that point, one of the brightest stars in Carina. In the middle of the 18th century, Nicolas Louis de Lacaille mapped and gave the stars of Argo Navis Bayer designations. He assigned the then 2nd magnitude star the Greek letter Eta. Subsequently Eta Carinae dimmed, and by 1782 it appeared to have reverted to its former magnitude. In 1820, it was observed to be growing in brightness again. By 1827, it had brightened more than tenfold and reached its greatest apparent brightness in April 1843. With a magnitude of 0.8, it was the 2nd brightest star in the nighttime sky, despite its enormous distance at 14.5 meters to another light source about 10 kilometers away, which would appear almost as bright as the candle. Eta Carinae sometimes has large outbursts, the last of which appeared in 1841, at around the time of its maximum brightness. The reason for these outbursts is not known. The most likely explanation is that they are caused by a buildup of radiation pressure caused by the star's enormous luminosity. After 1843, Eta Carinae faded yet again, and between about 1900 and 1940 it was only 8th magnitude, invisible to the naked eye. A sudden and unexpected doubling of brightness was observed in 1998–1999. In 2007, at magnitude 5, Eta Carinae could once again be seen with the naked eye. In 2008, the formerly clockwork regularity of the dimming was upset. Following its 5.52-year cycle, the star would normally have started its next dimming in January 2009, but the pattern was noticed starting early in July 2008 by the Southern Gemini Observatory near La Serena, Chile. Spectrographic measurements showed an increase in blue light from superheated helium, which was formerly assumed to occur with a wind shock. However, if the cause is a binary star, it would be located too far away at this point in time for the wind to interact in so significant a fashion. There is some debate about the cause of the recent event. In 2011, light echoes from the 19th-century great eruption of Eta Carinae were detected using the U.S. National Optical Astronomy Observatory's Blanco 4-meter telescope at the Cerro Tololo Inter-American Observatory. Analysis of the reflected spectra indicated the light was emitted when Eta Carinae was a 5000 kg 2–G5 supergiant, some 2000 K cooler than other supernovae imposter events. System and properties: this stellar system is currently one of the most massive that can be studied in great detail. Until recently, Eta Carinae was thought to be the most massive single star, but in 2005 it was proved to be a binary system. The most massive star in the Eta Carinae multiple star system probably has more than 100 times the mass of the Sun. Other known massive stars are more luminous and more massive. Stars in the mass class of Eta Carinae produce more than 1 million times as much light as the Sun. They are quite rare, only a few dozen are present in a galaxy the size of the Milky Way. They are assumed to approach the Eddington limit, that is, the outward pressure of their radiation is almost strong enough to counteract gravity. Stars that are more than 120 solar masses exceed the theoretical Eddington limit, and their gravity is barely strong enough to hold in their radiation and gas. Eta Carinae's chief significance for astrophysics is based on its giant eruption or supernova imposter event, which was observed around 1843. In a few years, Eta Carinae produced almost as much visible light as a supernova explosion, but it survived. Other supernova imposters have been seen in other galaxies, for example the possible false supernovae SN 1961V and NGC 1058 and SN 2006JC and UGC 4904, which produced a false supernova, noted in October 2004. Significantly, SN 2006JC was destroyed in a supernova explosion 2 years later, observed on October 9, 2006. The supernova imposter phenomenon may represent a surface instability or a failed supernova. Eta Carinae's giant eruption was the prototype for this phenomenon. One remarkable aspect of Eta Carinae is its changing brightness. It is currently classified as a luminous blue variable binary star due to peculiarities in its pattern of brightening and dimming. Surroundings. Eta Carinae lies near the center of the Trumpler 16 star cluster, which is, together with Trumpler 14, one of the main star clusters of Carina OB1, which is, together with Carina OB2, one of the main stellar associations of the Carina Nebula. The position of the star within its inner regions suggests that it may have been formed as the center of mass of the molecular cloud during the formation of Trumpler 16. Its position, together with its extreme luminosity, has notable effects to the other stars of the cluster. Eta Carinae is surrounded by the Homunculus Nebula, a reflection nebula which is itself a part of the much larger Carina Nebula. The Homunculus Nebula is composed mainly of dust which condensed from the debris ejected during the Great Eruption event in the mid-19th century. The nebula consists of two polar lobes and a smaller equatorial skirt. Surrounding the homunculus is an outer region of debris which shows an emission spectrum. This region has complex morphology with knots of material and highly collimated jets. The velocity of this material is of the order of 2000 km per second. Chandra X-ray observations show a relatively strong X-ray source in a horseshoe-shaped region surrounding Eta Carinae, indicating strong interactions between the outer ejecta and the ISM. X-ray source. For U1037 as Eta Carinae. Three structures around Eta Carinae are thought to represent shock waves produced by matter rushing away from the superstar at supersonic speeds. The temperature of the shock-heated gas ranges from 60 amK in the central regions to 3 amK on the horseshoe-shaped outer structure. The Chandra image contains some puzzles for existing ideas of how a star can produce such hot and intense X-rays, says Professor Chris Davidson of the University of Minnesota. A spectroscopic minimum, or X-ray eclipse, occurred in July and August 2003. Astronomers organized a large observing campaign which included every available ground-based and space observatory, including major observations with the Hubble Space Telescope, the Chandra X-ray Observatory, the Integral Gamma Ray Space Observatory, and the Very Large Telescope. Primary goals of these observations were to determine if, in fact, Eta Carinae is a binary star and, if so, to identify its companion star. To determine the physical mechanism behind the spectroscopic minima. And to understand their relation to the large-scale eruptions of the 19th century. There is good agreement between the X-ray light curve and the evolution of a wind-wind collision zone of a binary system. These results were complemented by new tests on radio wavelengths. Spectrographic monitoring of Eta Carinae showed that some emission lines faded every 5.52 years, and that this period was stable for decades. The star's radio emission, along with its X-ray brightness, also dropped precipitously during these events as well. These variations, along with ultraviolet variations, suggest a high probability that Eta Carinae is actually a binary star in which a hot, lower-mass star revolves around I Carinae in a 5.52-year, highly eccentric elliptical orbit. The ionizing radiation emitted by the secondary star in Eta Carinae is the major radiation source of the system. Much of this radiation is absorbed by the primary stellar wind, mainly after it encounters the secondary wind and passes through a shock wave. The amount of absorption depends on the compression factor of the primary wind and the shock wave. The compression factor is limited by the magnetic pressure in the primary wind. The variation of the absorption by the post-shock primary wind with orbital phase changes the ionization structure of the circumbinary gas, and can account for the radio-light curve of Eta Carinae. Fast variations near periasteron passage are attributed to the onset of the accretion phase. Future prospects: because of their disproportionately high luminosities, very large stars such as Eta Carinae use up their fuel very quickly. Eta Carinae is expected to explode as a supernova or hypernova sometime within the next million years or so. As its current age and evolutionary path are uncertain, however, it could explode within the next several millennia or even in the next few years. LBVs such as Eta Carinae may be a stage in the evolution of the most massive stars. The prevailing theory now holds that they will exhibit extreme mass loss and become Wolf-Rayet stars before they go supernova, if they are unable to hold their mass to explode as a hypernova. More recently, another possible Eta Carinae analog was observed, SN 2006 JC, some 77 million light-years away in UGC 4904, in the constellation of Lynx. Its brightened appearance was noted on October 20, 2004. And was reported by amateur astronomer Koichi Itagaki as a supernova. However, although it had indeed exploded, hurling 0.01 solar masses of material into space, it had survived, before finally exploding nearly 2 years later as a Mag 13.8 type of supernova, seen on October 9, 2006. Its earlier brightening was a supernova imposter event. The similarity between Eta Carinae and SN 2006 JC has led Stefan Imler of NASA's Goddard Space Flight Center to suggest that Eta Carinae could explode in our lifetime, or even in the next few years. However, Stanford Woosley of the University of California in Santa Cruz disagrees with Imler a unregistered trademark S suggestion, and says it is likely that Eta Carinae is at an earlier stage of evolution, and that there are still several stages of nuclear burning to go before the star runs out of fuel. In NGC 1260, a spiral galaxy in the constellation of Perseus some 238 million light-years from Earth, another analog star explosion, supernova SN 2006 GY, was observed on September 18, 2006. A number of astronomers modeling supernova events have suggested that the explosion mechanism for SN 2006 GY may be very similar to the fate that awaits Eta Carinae. Possible effects on Earth. It is possible that the Eta Carinae hypernova or supernova, when it occurs, could affect Earth, which is about 7,500 light-years from the star. It is unlikely, however, to affect terrestrial life forms directly, as they will be protected from gamma rays by the atmosphere, and from some other cosmic rays by the magnetosphere. The damage would likely be restricted to the upper atmosphere, the ozone layer, spacecraft, including satellites, and any astronauts in space. However, at least one paper has projected that complete loss of the Earth's ozone layer is a plausible consequence of a nearby supernova, which would result in a significant increase in surface UV radiation reaching the Earth's surface from our own Sun. At least one scientist has claimed that when the star explodes, it would be so bright that you would see it during the day, and you could even read a book by its light at night. A supernova or hypernova produced by Eta Carinae would probably eject a gamma-ray burst out from both polar areas of its rotational axis. Calculations show that the deposited energy of such a GRB striking the Earth's atmosphere would be equivalent to 1 kiloton of TNT per square kilometer over the entire hemisphere facing the star, with ionizing radiation depositing 10 times the lethal whole-body dose to the surface. This catastrophic burst would probably not hit Earth, though, because the rotation axis does not currently point towards our solar system. If Eta Carinae is a binary system, this may affect the future intensity and orientation of the supernova explosion that it produces, depending on the circumstances. Cultural significance. In traditional Chinese astronomy, Eta Carinae has the names Xinqian and Foramen. It is also known as E micro or plus or minus A, referring to sea and mountain, an asterism that Eta Carinae forms with S Carinae, I Centauri and I Muscae. In 2010, Astronomers Dwayne Hamacher and David Frew from Macquarie University in Sydney showed that the Burong Aboriginal people of northwestern Victoria, Australia, witnessed the outburst of Eta Carinae in the 1840s and incorporated it into their oral traditions as caloric war, the wife of war. This is the only definitive indigenous record of Eta Carinae's outburst identified in the literature to date. See also, bipolar outflow, Homunculus Nebula, LBV 1806-20, List of largest stars, List of most luminous stars, List of most massive stars, Pistol star, SN 2006 GY. Notes. References. Cited text, Wagman, Morton. Lost Stars, Lost, Missing and Troublesome Stars from the Catalogues of Johannes Bayer, Nicholas Louis de la Caille, John Flamsteed, and sundry others. Blacksburg, Virginia, The McDonald and Woodward Publishing Company. ISBN A978-0-939923-78-6. External links, NASA image released February 24, 2012, HST Treasury Project and general information on Eta Carinae, Eta Carinae profile, is there a clock in Eta Carinae? Euro-Brazilian research about the star, broadband optical monitoring, X-ray monitoring by RXTE, ESO press release about the possibility of a supernova in 10 to 20 millennia, the 2003 Observing Campaign, Davidson, Chris A. al. An unusual brightening of Eta Carinae. The Astronomical Journal 118, 1777. Bibcode, 1999 AJ, 118.1777 DDoI, 10.1086/301063. Nathan, Smith. The Behemoth Eta Carinae, a repeat offender. Astronomical Society of the Pacific. Retrieved August 13, 2006. Eta Carinae at Constellation Guide, Eta Carinae at Simbad.